day 248. My name is Katie and I took speech science just a couple of years ago, and I really wanted to come back and do an honors project with Dr. Vinny because I just love this class so much, and it's really what I want to kind of zero in on when it comes to speech language pathology. So today I'm going to be talking you through the Sing and See student lab. Now there's going to be some different labs that you do in this class using the software called Pratt, but this is something a little bit different. Sing and See is actually a visual feedback software. So if you were to sing into a microphone, it gives you back visual feedback about, spectrogram analysis and definitely pitch recognition. And so that is the lab that you guys are going to be doing in this class. And the reason why I wanted to do this lab is because singing is actually the reason why I went into speech pathology. I've been a singer my whole life. I love to sing. I sing everywhere I go, and it's just kind of a part of me. But I knew I didn't want to go into it as a full-time career, and I also knew that I wanted to help people along the way. And then I found speech pathology, and I was like, it's the perfect mix of all the things that I love to do. And so I've always seen the connection between singing and music and speech pathology. And so I wanted to bring that to light in this lab. But I do know this one thing, not all of you are super into music, and I totally understand that. That would be like asking me to run a marathon when I clearly cannot do that. And I know that a lot of you just really haven't had a lot of exposure to music theory, notes of the piano, stuff like that. And so I really wanted to give you this kind of supplemental video to kind of walk you through how music happens, what it looks like, different note names, octaves, stuff like that, that will definitely relate to this lab and most definitely relate back to the stuff that you're learning in speech science. So that's what I'm going to be doing today, so just strap in and let's get started. Alright, so the first topic that I want to talk about is note names. So if I bring out my handy dandy piano here, this is a piano. And each one of these keys, so each one of like this C, D, E, those are all note names. And so if you look at this piano, you'll see that it goes all the way from C, D, E, F, G, A, B, and then it circles all the way back around to C. And so realistically, if we were to look at a piano, because obviously a piano isn't just these 8 notes, it would start all the way over again. So after C comes D again and E again and stuff like that. So that is what the piano kind of looks like, and we'll talk about these black notes later. The next topic I want to talk about is something called a whole step. So if you look at this piano, you'll see that there's some white keys that are right next to each other, and there's also some keys that are kind of right next to each other, but they have a black note right in the middle. So when two keys are right next to each other, so if we have C and then D flat or C sharp, these two notes right here, those notes are a half step away from each other. And that is the smallest amount of interval, is what we call it, that you can have between two notes. So B and C are going to be 1/2 step away from each other because they are right next to each other. And now if we do some pretty simple math here, 1/2 plus 1/2 equals a whole, right? And so that's what we get with whole steps. So a whole step is going to be 2 half steps. So if you go from C to C sharp, that's 1/2 step because they're right next to each other. And then if you go from C sharp to D, that's another 1/2 step. And so you would say that C and D is 1 whole step away from each other. And you're probably wondering, what was I saying with like C sharp, D flat, all that type of stuff? Those are called accidentals, and those will become important in this lab too. So when you look at this piano and you see C sharp or D flat, the sharp means that you raise a note a 1/2 step, and then a flat is going to lower a note 1/2 step. So if you were to take the note C and raise it 1/2 step, that's going to be C sharp, and that's going to be the note in between C and D. So remember how I said that C and D were 1 whole step away from each other? C and C sharp are 1/2 step, and so is C sharp and D. So it's kind of like the note in between C and D. And if we take another example, let's do F and G. So if you take F and G flat, those are 1/2 step away from each other. Also, if you take G and G flat, those are 1/2 step away from each other. And then F and G are 1 whole step. So that makes G flat the note in between F and G. And you're also probably wondering, well, why is it C sharp and D flat? Why is it D sharp and E flat? That gets kind of confusing, I know. But remember how I talked about that sharps raise a note a 1/2 step? Let's take G and A for example. So you know that G and A are 1 whole step away from each other. So realistically, there can only be 1 note in between G and A, right? And then if you were to take the note name A, so this one right here, there's only one way to go down from A, and that's A flat. But if you were also to take G and try to go up to A, there's only one way that you can get up to A, and that's G sharp. But does that mean that they're two separate notes? Well, no, because there's only one whole step in between G and A. So if you were to look at A flat and G sharp, that's the same note. I know that gets really confusing, but you will be fine, I promise. So next I want to talk about a term that you've probably already talked about in speech science, and it has a very similar connotation in music, and that's called the octave. So you know that an octave in speech science means that it's just a doubling of the fundamental frequency, right? Well, in music, it's pretty similar the way the octaves work. So remember my handy dandy little piano here. Remember what I said about how you go C, D, E, F, G, A, B, and then you circle all the way around back to C. So this makes up one octave. And so if you take this C, so the lower C, and then this higher C, they are one octave apart. And it's really cool because you're going to see when you try to analyze your speech and with the frequencies, this is going to be a proportionate frequency to this last C. And that's why C's and lower and higher octaves sound like the same note. And they really are the same note, but if you think about it, they're not exactly the same note because the lower C has a lower frequency and the higher C has a higher frequency. But because they're proportionate with each other, they do sound like exactly the same note. So if you were to take two notes, so I'm going to pick A for example, A, see, they sound like the same note, but you can tell that they're different because the frequencies are different. And so that leads really nicely into the last topic I want to talk about. And that is going to be those little numbers right next to the note names. So you obviously know that the piano is a lot bigger than just these 8 keys right here, right? But then when you look at a piano and you say, okay, go play a C. Well, which C are you referring to? So that's why we use note numbers along with note names. So that if I say, okay, go play a C3, then you know exactly which C that I'm talking about. And then to throw in some speech science terms, then you also know exactly what frequency I'm referring to. Alright guys, so that completes my little theory lesson for you guys. If you still have any questions, please feel free to ask Dr. Vinny. I'm sure she can be able to answer any of these questions. And I've also included in your lab a couple of diagrams. So on the second page, you're going to see a piano that's labeled pretty similarly to this one. It's just a little bit more long, I guess, and it's labeled with C, D, E, F, all that type of stuff. And then if you look directly below that piano, you'll see that I put a piano that has all the frequencies for each of the note names there. So it kind of gives you a visual of, okay, so the lower note names actually do have lower frequencies and the higher ones have higher frequencies and stuff like that. So I really hope this helped you guys out, and good luck!